I'd like to talk about an exceptionally powerful tool called law extension. Law extension is an incredible tool, actually. It's one of my personal favorites. I use it to create flanges. I use it to create any kind of surface that needs to either come up at an angle relative to a face or relative to a vector direction. You have things like being able to control the shape with a spine as well, and various methods to create a length law and angle laws. Now the way this works, pretty simple, is you specify your base profile. So I'll pick my curves. You'll see here all three of these in the chain are selected. Tangent curves up here are selected. Reference faces in this case, because I'm using face, are these faces. Now that I have those faces selected, let me just quickly change this to none. I have a length value coming up off of this curve at 42 millimeters, and I have an angle value of 69 millimeters. And you can see from 0 to 90 and so on and so forth all the way around, you can reverse this 90 degrees and have it go in the opposite direction. You'll see these handles on the actual, let me get this out of the way. You'll see these handles at one end, and this handle here controls the angle, and this controls the length. You'll notice under the length law that I have the ability to change this from constant, and the same thing from angle, from constant, and I have all my law variation types. In this case, I'll just simply say linear. Once I specify linear, you'll notice the opposite end. I have another handle that appears, which allows me to adjust the height at this end. I can say cubic, and you'll notice that this now has an S shape. I can do the same with my angle law. I'll go to linear, and now I'll have a handle at this end, which allows me the independent control at that end. I also have cubic. You'll note that I have various methods by equation, by law curve, and multi-transition. With this multi-transition, I'll use that one as an example. I can come in and pick a point on that curve, and once I've selected that point on that curve, you'll see it's giving me this little warning. I have a tiny length. So if I come over here and specify 10, you'll note that I'm coming from 0 to 10. So if I go to this end and I pick this and I transition up, I'm going to 10 millimeters right here. And at this end, I'm going to go up higher. And at this midpoint, I'm going to reduce it. These are currently locked. Let me add another point in. So I'll come in, I'll pick another point here, and anywhere on this curve that I specify a location, I can now adjust that height again, and this is using the multi-transition. The transition is currently set to linear. I can say blend and have a nice shape at that point. Here's the list of the points. So if I want to, I can come into a point, and that's specified as a constant. Maybe I'll say blend. Now you can see I have a nice blended shape between those 2 points. So at each individual location, I have the ability to specify the type of transition that I want. Bring this up. There we go. Bring this one up a little bit. And you can see it gives you a location point. And I can again move this point along that edge as well. You can do the same thing with angle law, and I'm going to come back and do a lecture specifically on these law types and law values. I just wanted to give you an idea now the absolute power that law extension has. Select OK, and there's my law extension. And again, you'll note that the angle value is based off of this surface. Now, a lot of times, let me go ahead and delete that, you're going to need a surface at an angle based off of a vector. I'll specify my base profile. Again, it's on that curve or on that surface. This time the vector I'll use the z-axis, and I'm just going to change this back to constant and constant. You'll see here's my 0, There's my 0, and here's my 90. So based off of that vector, I can come in, specify the angle that I need. So this angle would be the equivalent to your draft angle, or die line specifically. This is a great tool to make your first flange for a Class A surface. So when you're doing your hems and flanges and such, this is a really good way to do that because you can specify a vector and control that first flange based off of your cut line. So I have other options, and these options again are good with, I can again adjust the height, adjust my angle. These other options are also good with the face type. I'll come down, and under extension you'll notice it says none. If I select on none, I can specify symmetric. And you'll see here I have a symmetric value that appears at the other side of the surface. And again, if I change this from, let's say, linear from constant, you'll see that it remains symmetric across that surface. I also have asymmetric. With asymmetric, I have the ability to call out a different length. And you'll also notice that with the asymmetric, I have the ability to say right now it's constant and linear. So pretty much every single input that I have can be done in such a way. Notice I can also go negative to come up and pass the surface in the opposite direction. Okay, let me double click on this. You'll also note that when I am going through, and depending on the type of law and where the law is set up and what I'm doing, again, I can reset and take me back to 0. So I get these little buttons that'll pop up and help me to manage my data. Another thing that I have down here are my tolerances. Merge faces if possible. You'll notice that I have three curves in the section and it's merged them into one face. If I do that and turn that off, you'll see that these are now 3 individual faces. You may need to do that. If you want to, you can do an advanced curve fit, and you'll see this in all the other surfacing tools that are based off of a section, is that it allows you to rebuild the section based off of the math that you want to put in. You also have the ability to use a spine. So if I want to, I can say curve. I want to use this. So now I'm using a vector and a spine, so this way I know for a fact that this surface is radial to this spine curve. Maybe this is a linear spine, and it's also using this vector to indicate my angle. Let me come in here. We'll just simply go to constant. I don't have an example for miter setup. This is just for corners, so if I have a corner actually set up on the section, what happens as the surface extends out? Does it stay sharp? Does it go sharp? Or does it go into a blended condition? So those are the basic functions and uses for law extension. Again, this is a great tool to create your first flange from. I'm going to come in and just simply select OK, and with that, if you needed to, again, create a blend for your first flange, you can come in here, say face blend, select U, reverse, select U, reverse, rolling ball. We'll just simply say circular, blend width, I'll say 10. I'll trim everything up, and that would be your first flange coming off of your cut line. So that's one method. Again, I use law extension quite a bit in modeling. It's a great tool, very easy to use, very powerful, extremely robust.